David Bernstein, and I'm with Techniques of Design. And hopefully what we will talk about today will be valuable to you. The thing that makes me a little concerned is just that we don't have a lot of time together. And really I want to give you value, because I know that there's a lot of ongoing learning that's involved in the process of being a developer. And some of that learning is very rich and empowering, and some of it is kind of like so-so. And I hope that this will be very rich and empowering. We're going to be talking about something that's kind of basic, kind of stuff you already know. But hopefully it will give you a lot of value just to keep it on top of mind. And hopefully we'll also go into it in a little more detail than perhaps you're used to. Okay? So I'm sure you already are familiar with a lot of these terms that we'll be talking about. But hopefully, as we get into it, you can see how these ideas can actually help us discover lots of other things, including practices that are really valuable to us as developers and principals. We're going to talk about what is quality software. And I know we all kind of have different views of this, and I think people who are not in the business that we are in as developers sort of see software quality maybe a little differently than we see it. A lot of times users don't have a direct experience of software quality, you know? But nonetheless it still impacts them in many ways. It's kind of interesting. I was reading some things online a few weeks ago. They were talking about how software quality is not all that important because users don't have a direct experience of it. And I kind of disagree. And maybe at the end of our conversation, we can talk a little bit about that, and you let me know what you think. So my name is David Bernstein, and my company is called Techniques of Design. And this is my blog. So I am writing about this kind of stuff. So if you want to know a little bit more about it, feel free. I have also given you a flyer which talks a little bit about my class that's coming up in the end of June, June 30th and July 1st, where we dive into these ideas in a lot more detail. And these ideas are really based on a lot of stuff from a lot of other people. So wasn't it Newton who said we stand on the shoulders of giants? And indeed, there are a lot of giants in our field. And I just sort of picked the top 10 people that have influenced me a lot in terms of software development and sort of re-inspired me. And actually, there's one other person who kind of inspired me in development who's actually here with us tonight, and I've worked with quite a bit, Rod Clare. Rod and I did a lot of training together in the past for another company, and we're both independent now. It's great to see him. So feel free to heckle me if you like.
I don't have anything to throw.
Oh no, bummer. We got a Dr. Pepper. So let's start out with a very simple question. What is software development like? And this is one of the things that I like to ask developers when I get to work with them or meet them and talk with them, which is, do you think software development, I want to ask you guys too, is more art or science? I don't think there's a right answer here, but I just want to know your feeling. How many people think that software development is a lot of science? Very interesting, very interesting. How about a lot of art?
Yeah.
Fascinating. Fascinating. And by that, what we mean is creativity, right? That there's a lot of sort of filling in the dots, seeing the big picture, integration. And, you know, I feel like we're kind of lucky because a lot of other people in the creative arts, you know, painters and poets and things like that, they get the kind of satisfaction that we get as developers, but they don't get paid as much. So I think, you know, we're very fortunate in that, you know, people actually pay us to be creative and to think creatively. And indeed, you know, I think we all know as professional developers that the typing part is the most trivial part of what we do, right? And the thing that really distinguishes a great developer from a good developer is really their ability to sort of penetrate into problems, to see the essence of a problem and then come up with a solution, to model it. So in a lot of ways, we're modelers, aren't we? We think about a situation, a problem, a process that needs to be created, and we think about how to model it in such a way that not only accomplishes the task, but even goes a little bit further. that makes it so that it's understandable and comprehensible. So we rely very heavily on metaphor, on our language skills, on our ability to abstract and visualize. All these things we are experts in. And yet, we don't oftentimes recognize that. It's one of the things that we get to exercise all the time. Sometimes I think now that I'm over 40, I have to go to the gym to, and you'll notice this when you get over 42, to not be very, very heavy. So I was sort of visualizing in the gym, what if I went to the gym every day, like I do 6 days a week, but only exercise this one muscle? Right? And by the end of a year or two, I would, if I had 3 hours, 4 hours, 5 hours a day, I'd have a very big left arm. And that's what we do as developers. We exercise that visualization muscle. And as a result, we're really good at it. And sometimes we wonder why our clients, our customers, our end users can't see a system in their head and tell us how to, what they want. We forget that we are experts at this, and this is what we do for a living. And a lot of other people, they have a hard time sort of seeing what could be. They can recognize it. It's like the old saying about art. You can recognize what you like. You can't necessarily envision it if you don't see it. So that's why I'm a big believer in agility, as you'll see, because agility gives me the ability to go back to my customer very frequently and say, okay, is this what you want? Can I make it better for you? When I was in college, I read a book called Physics and Philosophy by Werner Heisenberg. Does anyone know who Heisenberg was? He's a contemporary of Einstein, and like Einstein, a very creative man, somewhat of a philosopher as well as a physicist. And those guys, those physicists, since they were dealing with very abstract realms, were quite a bit into philosophy as well. And I remember in the book, and I even remember the page number, it was on page 160 of his book, Physics and Philosophy, he said, when you're talking about the subatomic state, invariably you're led to the question, what is it like? And he said, that's the wrong question to ask, because it's not like anything. We have no direct sensory experience of it. It's something that we can only transcribe mathematically. And a lot of times, I kind of feel like that's what I'm doing as well when I'm working in software, because it's really not like anything else. And we kind of try to make it like different things. And that's good, because that's the only way we can understand. But it's also got its limitations. We've got to be aware of that. So what is software development like? I think that's been a question that a lot of people have tried to address through the ages. The ages being about 40, 50 years now that our industry is, a very young industry. And I think the first thing that people latched onto is that it's like construction. That's kind of the metaphor that a lot of managers have presented to me, that software development is like, building a building or building a bridge or something like that. But I don't necessarily think that's really true. Because I can take a blueprint for a building, this building for example, and give it to 10 different construction firms. And I'll get essentially the same building out of all those 10 different firms. Maybe some things will be a little bit different in its form. Maybe they'll use a different kind of window, or they'll paint the walls a different color. But essentially it'll be the same structure. I can give a spec to 10 different developers. And although it may behave in a very similar way, the internal structure will be radically different. So we're in a very different situation, than civil engineering. Because really, we don't have a blueprint in software development. We have a specification. And that's inherently ambiguous, because it uses language. And language is inherently ambiguous. And we know this, right? How many times have you gone to the spec and gone, wow, there's a big hole here. We have to figure out. And we're thinking and doing design as we go. I mean, it's just the nature of it. And even if it is like completely, perfectly defined for us, which I haven't experienced yet, but I believe that maybe it could be for someone, it certainly won't be probably exactly what the customer wants once they actually use it for a little while.
Say that of a building, though, too. Yeah. You can say that of a building, though, too.
That's true. That's true. And in fact, it's kind of interesting because there's a lot of this actually comes from architecture, building architecture, from Christopher Alexander onward. And they're looking at how do we build buildings that are repurposable, right? Because they realize that buildings that were built, 50 years ago in a residential neighborhood now are commercial areas, and they need to restructure it. So they're building buildings to actually gut out and repurpose.
Quick question.
Yes, please.
Isn't the whole idea of software patterns borrowed from the architecture when they decided to standardize things and have a book of architecture rather than just John Wayning everything?
Yes.
And we're getting to that point now where we're starting to decide on good patterns, things we should structure. So isn't that in a sense a blueprint or a pattern to use?
It's not quite a blueprint, but it's definitely a pattern. And patterns are incredibly valuable. Has anyone read the book by Christopher Alexander called The Timeless Way of Building? Christopher Alexander builds buildings. He wrote this book, when was it? Like in the 70s?
70s, yeah.
Yeah. And I guess Eric Gamma, when he was going to school, read the book and made a very big impression on him. And he wrote his doctoral thesis on it. He said that, well, there's patterns as well in software. And of course, his doctoral thesis, he brought 3 other guys in, and it became the famous Design Patterns book. How many people have read the Design Patterns book? Okay, now look around the room when I ask this next question. I love this. How many people understand that book? Okay, you're a special crowd. Like 3 or 4 people here.
Very special crowd.
Yeah, please.
Since I think I was the only one who raised my hand on Christopher Alexander, I should mention that it was very specifically not about blueprints, right?
Yes.
I mean, it was an antithetical. It was basically that a guy constructing a building who knows the patterns intrinsically in their relationships to each other will just by his nature build things a certain way. And it very specifically was saying things like the corners should not be square. Things should not be positioned exactly right and measured exactly right and all of that, because that's something that's dead. At the very point that it's created, it's dead, right? Because it's all about liveness and a place that breathes and lives and that people want to be. Well, I think that was part of why patterns were so intriguing to the Gang of Four, is that I think they recognized that element of software, that it doesn't really correspond to a blueprint. There's a liveness to it. And you can look at code sometimes and you can see it and you're like, wow, that's amazing. And you look at other code and you're like, this is a total piece of crap. And it might use all the patterns and be a piece of crap, right? And it might use a great blueprint like, say, Pet Store and be a piece of crap. But there's a way of knowing if you really have it all intrinsically known. And the ending of that book, like I put it on. I read like 2/3 of it and then got lost. And I came back and I actually read the end of it, and it was literally like a month ago. And I was really amazed. And I've lost that moment now, and I don't even remember what it was that amazed me. But if you get a chance, do read it and read it through to the end. It was really eye-opening.
It's great. In fact, my favorite quote of that book is in the end. I'll give it to you because it's on page 545. I'm not idyllic or anything, I don't remember, but it just so happens that these 2 passages, I do remember the page number. So he says, in the end, this is Christopher Alexander speaking, in the end, patterns are not important. Gee, I wish he told me that on page 1. Because they taught us to be aware of what is real. So this I find is totally true in software as well. Design patterns are, I'm a big patterns guy. I really believe in patterns. And the reason is that they help me understand the forces of a problem. And once I understand a problem, then the coding of the solution is really easy, or at least far easier. The hardest part for me, and for most people I know, is understanding the problem. And when you can see that the problem has its own solution within it, I know this sounds philosophical, but it's really true, and it has a lot of practical applications that it's kind of comforting and interesting. And you can also see patterns as a thing to sort of strive towards. When you understand them as, maybe we use the term archetypical or conceptual or abstract, rather than something that, the canonical, this is a strategy pattern or whatever, then you realize that you don't have to ever achieve it 100% in any particular situation, but you could go there if you had to. And I like that because it gives me a lot of freedom to be able to defer things until later if I have to. Okay, I'm a big I'm a big believer in putting things off if we can. Yes.
I think another important aspect of the patterns book is simply that it provides us with a terminology that's necessary for people to communicate
Yes.
like ideas. I mean, before that, these patterns are out there, but we really didn't have names for them, so we couldn't talk about them without sort of describing them, which is hard to do. So having a terminology was something that we didn't have before the patterns were sort of created, and that's important for us to be able to simply communicate.
I so agree. Absolutely. And you know, it's like doctors, right? When you see two doctors talking to each other, they just say a few words in Latin to each other and they walk on. But they've communicated volumes, right? Volumes of information. And to me now, that's how patterns are. When I talk to Rod or some of my other colleagues and we're talking about, oh, well, you know, we should probably use a decorator here, or I think there's a bridge in that situation, we're really communicating lots and lots of information. And it helps tremendously for us to see that big picture. You're going to have to invite me back when we talk about patterns.
Sure.
This is sort of foundational. We're not actually going to be talking about patterns, but we're going to be talking about what is good, what is virtuous in software, so that we have a way to evaluate why a pattern is useful, why a practice or a principle is useful. So that's the basic philosophy. But I get ahead of myself. Anyway, I don't think software development is very much like engineering in that sense, because there is no blueprint. I think software development is more like invention. A lot of the time, not all the time. Go ahead.
So why is software not like architecting buildings?
Oh, great question. Several reasons. What do we do when we architect buildings? Oh boy, there's so many answers to this, but I want to give you several. The first thing we do is we survey the area, right? And we figure out, you know, where we can lay the foundation, where the bedrock is, all that kind of stuff. And then we create the blueprint. And then that's where a lot of the creativity comes in for the architect. And then they bring in the construction company and they read the blueprint and actually comply. Okay.
But once the blueprint is done, the architect is done to a large extent.
Yes.
But so getting to that point, since I was an architecture major in high school and minor in college, getting to that point feels to me a lot like software. I mean,
Except
if you look at Gary's buildings and stuff like that, you know, that doesn't look to me like anything like standard architectural. You know, oh, I'll just go get this wall piece and drag it over, and a design tool, and this door piece and drag it over.
But they fit together very nicely.
Well,
They
not
were
his buildings.
I think actually that's true. If you think that, I mean, there is a blueprint. I think there is actually a blueprint in software. But the process of converting that blueprint into actual usable software is automated. We call it the compiler. So I think the blueprint in software is the source code, the final source code
Oh,
that you build.
agreed. But getting to the blueprint feels to me exactly the same as when you're doing building architecture.
Oh, I see. So in that case, we're saying that we software developers are architects.
Yeah, sure. Like similar to building architecture.
I love that. And I would totally agree with that. But remember that,
Which is why your third bullet point up there made so much sense.
okay, so we're not the hard hats though. We're not the guys
Oh,
doing the
God,
construction.
no.
That's the compiler.
Yeah.
Cool. Yes.
In your third bullet point,
This one.
it's like when somebody says, well, when are you going to be done? And I said, well, are you going to start building the building before the architect tells you what's going to be the first floor?
Yeah. Really? Okay, so let's try a little experiment. I want you to come up with something. I want you to invent something really amazing, really, really amazing, totally new. It's going to change the world. It's probably solve the energy crisis or something like that. And do it in the next 5 minutes.
Go.
Go. You know, but that
Management.
feels like right. That feels like what management says to us a lot.
Oh, God.
You know, and how do we figure that out? Now, a lot of things we can know because we've done it before. But the stuff that's the funnest for us as developers are stuff that we've never done before, right?
That's the most important part for the company, too.
Yeah. Yeah.
No, not necessarily.
Well, I
In
mean,
fact, frequently it's quite the opposite, that by going off on some adventurous path, rather than doing something which is boring and about 50 times.
Well, there's that problem. And besides, the final architecture is usually chosen by a dartboard. By the management.
Yes.
Yeah, right. Completely out of context.
I do think more of us get to be Gary than actual architects get to be behave like Gary.
Yeah. Yeah.
So this is, of course, the waterfall approach. And I think managers find that it's very comforting to say, oh, we're in this phase and then we're in that phase. But of course, we know that reality is quite different than that. And in fact, the waterfall, the term waterfall was first coined by a guy named Royce at IBM. And he wrote a book and he talked about different ways of developing software. And on the very next page, when he described it, he said, oh, by the way, don't ever use it because it doesn't work.
He
But
was
no one
actually
ever read that
proposing
far.
the spiral model.
Yep.
First
Yeah.
page.
And about, I think it was about 1990, the military came out and said, it does not work.
But we love Ada.
Yeah.
Yeah.
That was hopefully a different department.
It was, and I know the admiral in charge.
So how many people here would consider themselves agilists? Good.
Hard time.
And of course, agility is a sort of a little bit different paradigm for doing software design. And I think that a lot of developers like agility, but a lot of management who are not familiar with Agile get a little scared because you can't give them a date when everything is going to be done. But if you think about it, we're saying that we're on a, given that limited resources are, every development project probably has limited resources, within the time span and the budget that we have, we can deliver the most value. Because it'll be what the customer wants the most. Because every 2 weeks or every however long your iteration like this, we're going to go back and say, okay, well, what are the next few features that you want? If we keep doing that, we're going to build a better system. So this is from the Agile Manifesto. Our highest priority is to satisfy customers through early and continuous delivery of valuable software. So the notion is that what we're actually delivering is value to the customer. Somebody's going to be using our software and they're going to derive value from it. So anything that gets in the way of that, that is, all sorts of fancy charts and graphs and, TPS reports and all those other kinds of things, are all getting in the way of building software. Now, as we start to build software in short iterations, and if you're not an agilist, this is actually true when you're building software in a waterfall methodology. It's just you think that your iterations are longer from version 1 to version 2, etc. Things have to change. We have to add new software. And when we do that, the question is, how do we do that in a way that is the most efficient and that doesn't degrade the quality of our code, that we're not hacking around? Because if we're building software in iterations, we want to make sure that the features that we add are with a minimal amount of reworking. And what we do does not break other clients that are using our software. So there's that saying, do the simplest thing that could possibly work. And I've seen this be an excuse for hacking and creating really, really bad code. And I've seen this also be a way of creating very, very high quality code. And my question is, what's the difference? Why does it work for some teams and not work for other teams? And I think that the answer really is that the teams that it's working for are paying attention to some very simple, specific things. And some of those things are code qualities, which is what I want to talk with you about. So what is quality? Quality,
Can I dwell on that last point for a minute?
please.
Because we had this debate with some of my coworkers, where one of my coworkers, his tendency is to write something himself that fulfills the minimum contract, and my usual approach is find somebody else's library who already does this thing. But there's a small integration cost. Now with Maven, admittedly, it's lessened if you know where it is because you just plug it in your palm and get it for free, right? But there's still the issue of looking for it, making sure that it's a current release, that it does the thing that you want it to do if you haven't looked at it in a little while.
Yes.
Something like that. So I'm just wondering how we could just talk a little longer about how do you determine whether the simplest thing is actually the thing that you can write quickly, or whether it's doing a little bit more groundwork that'll lay something out for the future, because it's one of arguments is we might be bringing in more than we need now. We don't want to make decisions too soon. But in my mind, if I need a string utility, I'm probably likely to need another string utility or something later, right?
Interesting.
I don't know if you have any other thoughts on that. If it's
I do actually. I have a rule of thumb, which is when is the simplest thing the right thing, and when is it not the right thing? Because clearly, doing agile architecture, that's the name of my course, agile architecture. So I first of all believe that there is such a thing as architecture and agility. I know some people don't think so, but I would disagree with that. But it's different. And you don't make all the decisions up front. And so the real trick is, what decisions must you make up front, and what decisions can you defer on? My rule of thumb on that really is this. If you can encapsulate the issue, then you can defer the issue until later without suffering a huge price later. If you cannot encapsulate the issue, then you better think about dealing with it now. So I know this is a quick statement, but it tends to work for me.
You mean like it's a separation of concerns there? Is that what you mean by encapsulate, where you can pull it out into a library or something?
Good question. And that's one of the things that hopefully we'll be able to get to that I want to talk about in terms of code quality. Because encapsulation, think of it just in the very simplest term, hiding something. Okay? So here's some examples of things that we really can't encapsulate unless we focus on it up front. How many people here have probably either done this yourself or know someone who has done internationalization after the fact? Okay? Nasty thing, isn't it? Like internationalizing a program that has not been built for an international market can be really a big pain. Why? Because there's so many different points that you have to touch to make that happen. Okay, so that's an issue of encapsulation. If you're going to be creating a very high availability database, to do airline reservations, you can't mock that up with a flat file. You got to think about some of those issues up front. Okay. But a lot of issues we can defer on. Sort of also related to your question of buy or build, that's a little bit harder, A lot of times, thinking about an overgeneralized API can also create some code quality issues. But if you're familiar with patterns like facade and adapter, they can help significantly so that your code is clean, but you're also then branching out into this other set of other people's code that maybe you just need a thin slice of. Good questions. So back to the issue of quality. Quality is something that, again, we kind of intuitively know. You know when you go to a good restaurant, quality service, or a fine piece of cabinetry is quality. But what is quality in software? It's a little less tangible for a lot of people. So how do you define quality? Is it that your code does the right thing? That it's relatively bug-free? That it executes quickly? That it's easy to extend? What is quality?
It depends on the viewpoint.
Depends. I like that. That's my favorite answer. Yeah.
Well, I mean, another software developer looking at someone's code is going to have one viewpoint. How hard it's maintained, how much corruption is in there, whatever. The end user, quality might be defined by the fact that the software is easy to use, it gets out of the way, he's not constantly fighting the interface or whatever. Just different things define quality.
Yeah, it's true. Someone said to me, actually, it's my hairstylist too. He's like really heavily into quality, and it's kind of weird. His store is like if you come in, he sets you out into a chaise lounge, and he says, "Do you want something to drink?" And like if you ask for a Coca-Cola, he only buys Coca-Cola from Mexico because they use pure cane sugar and use the old bottles. I mean, he's so into every last little detail. His name is Valentine. He's a pretty cool guy. And I said, Valentine, I learned so much from you about quality. What is quality to you? And he said, quality to me is endurance. Something endures, built to last. I thought that's a pretty good definition. He has no concept about software. He's not a software guy. But I think it really applies for us.
Well, not really agile, though, is it?
No. Agility is not about, it doesn't negate the concept of quality or the concept of something built to last. Agility is just the ability to be flexible. And in fact, one of the qualities that make things last is flexibility. Think about the reed blowing in the wind. Since it's flexible, it won't snap. So I think they're actually the same. Yeah.
I was going to make exactly the same point, that if your program is flexible, then it can last longer because you can make little changes to it so that it lasts.
Before it collapses under its own weight, everybody quits. And you're left with
All right.
a bunch of code and no one who's willing to work on it.
This
So what is that distinction between collapsing under its own weight, as you say, and something built to last?
I think software quality is something where I can test that piece of code very easily. If I can, it doesn't matter if I take that stuff and I can run my TDD or that maybe test or something, and it's successful. And if I again change it and run again and I know all the things before are success, then I'm comfortable with that code. But if there is no way for me to test whatever the other guy wrote before, then I think it's very hard to know.
Interesting. Now, notice the level of his statement. He's not saying testability just so he can verify that something works, but that testability tells him whether there's quality in existence or not. It turns out that, for me, it's one of the most powerful keys to determine if some code is high quality or not. As we'll see, because testability and code quality are very much reflective of each other. Great point. So I say, 20 years good.
I want you to, just if you back up just 1 second.
Please.
I did have one thing to say. When you say easy to understand,
Yes.
by who?
Great question.
Because most programmers worry more about what's inside the code than how it actually looks to the people who have to use it.
No. I mean, in terms of us as developers. So users don't have a direct experience of code quality. They understand the end effect, which is that it may be easy to use, relatively bug-free, that the company that delivered it can come out with new updates rather quickly. Those are side effects to code quality. I can show you some of my code, and we can say, oh, that stinks, or that's really elegant, or whatever, because we understand that language, the language of building software. And that's very much, as it relates to easy to understand, means how consistent or congruent the design metaphor is. Okay? Because really, what are we doing? We're throwing bits in a virtual world. I mean, inside a computer at microscopic levels. So what we're really thinking about is a metaphor that maps to that as well as our problem domain, so that we can make the computer do what we want it to do. That's, again, the aspect of the creative side of software. That's the fun part.
Weinberger said that quality is that what provides value to the end user. And so, from my standpoint, it's like, of course, so higher quality, more value, I guess you would say. But it was from the endpoint of the user, and so you go, well, how does that correspond to code quality, which you were talking about? You're sort of separating code quality from the end user experience, but and it seems to me the agile principles also go towards, what is of value to the end user, to the owner, is what you have to pay attention to.
Interesting. Yeah.
But to me, it's like, well, okay, so does that mean I can write a total piece of crap so long as the user's happy about what it gets, then that's good quality code?
And that's what the argument is online. Yes.
And my thought is, well, that's not likely to be true. I mean, in that, okay, so you may provide them everything they want right now, but if down the line they ask for a change, or they start getting bugs and you can't fix them or something,
and that's
so
the
it starts to impact the value at that point. And so there's a relationship there.
And I can't think of examples offhand, but I remember in the 80s there were several examples of this where version 1 of a product was enormously successful, and everybody's like, okay, we're waiting for version 2, and they couldn't get it done. As a matter of fact, I can think of an example, fortunately from some friends of mine. If you've ever seen a product or heard of a product back in the old days called Clipper, from a company called Nantucket. Yeah, man.
Database software?
Database software was a D-base compiler. And Rich and Brian were friends of mine. And I remember, just to give you a sense of how rich, how wealthy these people were, we would hook up at Comdex. And I met Rich down at at the casino. I said, Rich, come on, let's go and get dinner. He said, hold on, I have $20,000 on this hand. Just give me a minute. So I mean, he had no trouble dropping 10, 20, 30 grand a hand. Okay? So this guy was doing pretty good. And they're very, very smart people. But they were living in the constraints of a selector offset, 286 architecture kind of world. And they weren't really thinking in terms of, extendability. If you looked at actually some of their source, they had names like Plankton was like their general services. So they were, taking the maritime metaphor a little bit too far, I think. And as a result, they weren't able to come out with the next version. But I know a lot of companies have been in a similar situation. So I agree with you that it may not bite you today, but it will, if we think of our software as something that needs to last, needs to continue to provide value, that we can't just delete it and start over again to get version 2, then we got to think about quality.
So I hope you give this talk to managers as well, because I mean, obviously we're always up against, if we go by the definition you just gave, quality could be defined by, it did it in 1 week and that's what I need. Despite the fact all these other problems that would be coming down the road that you warned them about, and you said you really didn't want to do it this way, but they said they wanted it this way because time was of essence.
And by the way, we got to do that sometimes. We have to. And I'm not saying that's totally wrong. I'm just saying that we should be aware when we do it.
Right. When you do it,
Not as often.
it's not going to be necessarily
Are
quality
told.
software.
Yes, right. Well, hopefully we can push back.
I was ordered to produce a piece of software by a certain date, and 6 weeks later, the first bug report came in, which was basically a showstopper, which I discovered 2 days after I shipped it that it did not work. But they had been so adamant that we need it by June 3rd, and they didn't touch it for 5 weeks, otherwise they would have seen that bug right away. So
Yes, I've seen
it
people
was
do
an
that as
interesting
well.
summer because they just kept discovering bugs, and we kept thinking, how did it take them 6 weeks to find this bug?
Yes.
Get it in writing.
Right.
And so it seems to me that there's value in using quality as a noun and not as an adjective.
Yes, in fact, if we get there, and I'm really happy to have this conversation. I think it's much more fun than the slides, but in the slides I actually have 6 things that I define as quality.
My quick example is that I had a very technical product owner
Yeah.
who was able to say to us, when we said we were slowed down because we have a particularly tough thing to test, and we want to write tests around it, he said, I have a presentation to management, I have to make that date. Feel free not to write tests, we will write more after. But it's more important to me right now that we get that date, even if it isn't perfect and we don't have all the regression tests. The quality that he needed was timeliness.
Yes. Yes, and like we say, sometimes that's really important. And I mean, we live in a context of having to do business. But one thing I do want to say, a little caveat from some of the things that I'm hearing, which is I'm a big advocate of code quality, obviously. But what I'm suggesting, and I don't actually have time to cover a lot of the practices and principles that underlie the quality, but all of them are simple, super simple, that you can do without even ever having to think about it. Because I'm not about giving us more work to do. We have enough work to do. Okay? So the practices are things that we can do without even thinking about it. What we want to make sure we don't do is confuse lack of familiarity with complexity. Okay? So once we become familiar with thinking about software quality and building it in, making it our habit, that is what we do under stress. That's our habits. Then, because I've seen programmers be able to write high quality code and turn it out super fast, it's because it's just how they do it. So let me ask you a question. Given that anything, I mean, we don't know what could change, right? What part of our software do we need to build changeable? Silly question, right? All of it. We want to build our software so that all of it could be changed if needed. So again, I'm a big advocate of some very simple practices that help us with that. So correctness is not enough, is what I'm saying. And obviously, since the vast majority of time and money is spent after software is released, maintainability is a very critical part of the overall cost of ownership for software. So, things can change. Any number of things can change. We've certainly seen the list before. And how do we deal with it? Well, we want to pay attention to just a few things that are maybe impediments to making change easy. And if we pay attention to those few things, I think it takes the sting out of change, makes it easier. So, what makes code hard to change, and what makes code easy to change? I think that's a good question to ask. What would you guys say? What are some things that are impediments to change or make it difficult to change?
Dependencies.
Dependencies, that's a great example. Yeah, because if we have dependencies, and that's probably one of the most relatable examples, is if we do have dependencies in our code, then obviously when we change something, it could break 50,000 things. Yeah.
What I see often enough that kind of freaks me out is the lack of an IDE. When somebody uses VI or something like that, I have to think they're more reluctant to do refactoring because of the time costs.
Wait, what?
And I've had
VI is
people
not very
argue-
good for
I've
refactoring.
I've had people argue with me that they've got little scripts for VI and grep and whatever.
Yeah.
I don't buy
Well,
it. But they,
At least they have scripts. At least they're using regular expressions. That's good. But looking at the latest version of Eclipse, for example, just some simple refactoring tools is so valuable. Just so happy with it.
Actually went from VI to using Eclipse just recently. And it's like looking at refactoring. We just started a Java program and just kind of learning Java. It's like, you can do what? Do what? It'll do what? It'll rename everything. Good.
and are you more willing to do it now?
Well, oh yeah, absolutely. I wouldn't think about it.
So, something that is against making code would be something with like a high level of complexity, 400 line methods,
Yes.
lots of case statements.
Yes.
Pick your logic
Yes.
constructor.
So those are other examples of code that's hard to maintain, hard to extend. Peters, is that your name? I forgot. Yeah. Steve, sorry.
What I find is dissipating a decision across a lot of code. It's what I ask my students is, how many lines of code would you have to change
Yes.
to change the way that you log, the way that you do whatever?
Yes.
And if the answer is hundreds or even dozens, that's a bad answer. If the answer is 1, it's a good answer. If it's 0, it's a great answer.
Yeah. I fully agree. I absolutely agree. In fact, I strive in my software to make any change, any conceivable change, in only one place. And it may be several lines of code or whatever, but it'll be within one encapsulated entity.
Right.
Yes. Yes.
So I'll just mention that quite often I have seen situations where you might say, okay, well, I'm going to get rid of this switch statement and go with a polymorphic, like almost like a double dispatch model.
Yes.
And you think, oh, this really fits into the pattern model and all this jazz. The next developer comes along and says, what the hell are you doing? Because the abstraction and the interfaces actually make it harder to navigate around the code. Harder to actually understand what it's doing, even though you've now made it so that the code is never repeated any place, and all the behavior that's switching in and out is all in one spot, and it runs faster because there's not all these extraneous if statements, but the next developer does not know what it's doing.
You don't
And
want
that
to be too
ties into
clever.
what you're saying.
You don't want to be too clever. Right?
Well, but the
Obscurity
problem
is
right,
a bad
the problem is too clever is a purely subjective model.
So,
I
but
had a friend that was Lisp, and then he
Yes.
learned Java, and everything was tail recursive calls. Man, dude, I reduced your code. It was 2 pages down to 3 lines. I said, yeah, but nobody understands what you're doing or can change it.
And Java doesn't do tail recursion, so.
Well, whatever, recursive.
No, I'm just saying it does, but it doesn't actually does the elimination, so you can have stack blowouts.
Yeah.
But I think there is an answer to that, though. I mean, documentation helps, right? So,
Yeah.
you know, if you got something complex or something that you might be able to go back and look at it scratch your head.
Again, though,
programmer documentation?
again, though, complexity is in the eye of the beholder. It's like, well, this is
That is
obvious
true.
what it's doing.
That
So
is
why
true.
would I document what's obvious?
That is true.
So what you're saying is that we have to have sort of sort of a level set of knowledge, all of us, to understand some basic conventions, so that we all follow those conventions. I mean, how many people drove here today? Okay. And I assume that you drove on the correct side of the street. Well, yeah. Well, actually, depends upon what country you're in. Hopefully the right side. What would stop you from driving on the other side? Yeah, the other cars. I mean, there really is just a line painted there. But it's the fact that we all agree on that convention that we are able to move through traffic. Well, we got to have something similar in software. We have to agree upon conventions. And one of the quickest ways to destroy an architecture is to not understand it. And typically this is what happens because we get our very best and brightest to build systems, and then we bring on junior programmers to maintain it. And they go, what is this? Chain is what a thing? What a? And I don't understand it. I'm just going to put an if before I give a call to it and deal with it that way. And pretty soon we wind up with just a mess. Right? When the original intention was to be able to handle this in a very, what we call open-close way, or a way that's very extendable. Right? So part of the responsibility, like you say, is that we have to add documentation that says, oh, we're using this pattern, or we're using this convention. Please understand it before you go and hack it. But all of life is kind of like that. Yeah.
Well, I think it also helps if you stop somewhere in your code writing process and refactor and say, okay, it's time to clean up.
Yes.
I'm trying to get that job done, but I've got to stop, refactor, clean up because I know my objects have bled into each other because I'm trying to get to point A to point B.
Absolutely. And if you do TDD like this gentleman does, you know that you do refactoring all the time.
I was going to recommend 3 o'clock.
It's a good thing, I usually 11 and 3. Yeah, exactly. Or 11 and 4, depending on how late I am. Yeah. Yes.
I would suggest something that, practically speaking, makes code difficult to change, which is not really asking for code, but that's large amounts of persistent data.
Oh, interesting. Large amounts of persistent data being a...
Persistent. In other words, if you've got a bunch of data that was written out by your code, read in by your code, it makes it harder to change the code because you have to decide what you do, how you read in all this existing persistent data.
And in fact, this is a huge challenge now. I was just doing a podcast, and this was a question that was asked of me, which is, how do you refactor database code? Because obviously, when you're refactoring your executable code, your source code, it's easy to throw things out and change things around, but you can't do that with your customer's data, right? And it's a big challenge. And only now are we starting to see people build tools to do this. One of the tools is called Data Constructor by a friend named Max Guernsey, who's here in town. And there are people who are building other tools as well. But yeah, and the real challenge is, I think people think that they could go to from version 1 of the object to version 9 by making a jump. And I think that can be very dangerous. One of the things that we really want to do when we're doing that is to go from version 1 to version 2, which is all the way up, to make it metamorphosize or make it evolve. Because only then will those transformations really take effect.
So if you are going to do that, does that mean that you preserve versions 2 through 8 in the program you deliver to the customer? Or
If you
tell
need to
them-
migrate the data, you at least preserve the transformations.
And apply them serially forward or backwards.
Precisely.
Yep.
Yes. Yes. And in Java, serial for and being able to work with that can help you a lot. Yeah.
So I would challenge this principle because I think this is actually one that is often abused, and I think a lot of people do make the assumption that you should make all your software as changeable as possible in any dimension, and as a result, don't think hard enough about what is the likelihood of it changing all the time.
Interesting.
And I think that's actually I see more problems along this line of people inadvertently making things too flexible in a way that's unnecessary.
I see that a lot
It's
too.
kind of like considering the possibility that maybe people will be constrained by gravity, so we should design our buildings not to be limited by gravitational requirement, because maybe somebody will invent big floating bananas.
Yeah.
And it's like,
It's-
okay, it's
I've seen
possible.
that level of absurdity,
But,
like you
right,
said.
but
Yes.
I think a lot more common,
Yes.
though, in the context of
Yes.
it's much more like any interface, anything concrete is inherently wrong. Everything should be abstracted, and you think, okay, theoretically, I might not use a list structure ever again, but maybe in practice I know this is a list. I mean, sometimes it just goes to ridiculous levels, it seems to me, and you have mountains of code.
Yes.
It's an incredible abstraction over a very simple problem. You're like, well, why not
Especially if you're
simple?
having to add a lot of code. I mean, I think that's the key.
Right.
You see a lot of added code for things that aren't being used at that point in time.
I
Because
think it's a
maybe
big
they
trap.
would
I
be.
think today this is one of our biggest.
It is a big trap, and being a patterns guy and teaching patterns, I see this all the time. Because my students go, oh, I get it, and they start becoming what I call pattern happy. And they just throw patterns everywhere, and it's like, it's got to be great code because I'm using 17 patterns in this. It's like, no, it's way overkill, you know? And so, like you said, what is likely?
Right, it's also part of the design problem still. I think making it changeable in the ways that you expect you to make a change, which is the same skill that the design skill is anyway. It's like understanding the problem, therefore what the axes are, what you need to be flexible is key, right? It's like that's correct.
Yes.
And of course that's why it's hard, because it's a design problem again, so now you're screwed, right? You know, well, I don't know how to solve design,
Well,
but that's the hard part.
This is interesting because there is this level in search engine technology, they call it precision. When you're talking about precision, we're doing searches, it's the right keywords that get you the right results. So there's a level of precision of any level of abstraction. And it comes from understanding the problem. So again, and words are so blunt and it's so hard to articulate this, but what we're trying to do, the ultimate goal, is to be able to penetrate to what the problem truly is, understand its forces, and come up with its own solution. Excellent. Yes?
I think to Doug's point, though, that's part of the artistry of being a software developer.
Absolutely.
Knowing what those, what makes sense, what's the right thing to consider, and what the wrong things are to consider.
Yes.
And sometimes it's not obvious to anybody else, but somebody who's done it many times and has experience and has never seen a building float. So it's not going to happen.
Yes.
I think swing is a perfect example of this. Totally everything's abstract. We did it because we could, and then it ends up being this slow, big, fat pig that took into account things that people didn't really need to. He got his head handed to it.
Yeah, although I could kind of argue the other way as well. Swing is a monstrosity for sure, and even the first version of AWT. You look at the class hierarchy. One smell, we use this term. Something could be bad as a smell. One smell is huge class hierarchies, right? And very few things really lend itself to good huge hierarchies that are not taxonomies. If you look at JFC's class hierarchy, it's enormous. But they're doing a lot of reuse. It's kind of a special case thing. They pay a huge price for it in that nothing is reentrant in the GUI. But it's the trade-off they made. Yeah, we could probably come up with something a lot more simple. I agree. Steve, go ahead.
One of the things that I find in the patterns in the object-oriented space is when you write a piece of code, when you have a pattern and you're using the inheritance, it's frequently, very clearly, if you were to add some functionality here, you want to subclass this guy, and these are the methods you should override, and we've set them up. But it's frequently not easy to document. Not, what your code does today, but how it was intended to be extended in the future.
Yeah. I'm thinking about the main campus at Oxford University. There's the big Commons Hall, and they had these giant oak beams, huge oak beams in the hall. And this is a now 200-year-old building, and things are starting to fall apart. They were cleaning around in there, and they found this piece of paper lodged up in this giant beam up in the ceiling. And they pulled it down, and it had a map. And it had a map of the front lawn where there were these huge oak trees that they had planted 200 years ago. And they planted specifically for the purpose of replacing those beams. And they said, oh, and by the way, in 200 years, use these trees. We don't do enough of them. Yeah. Good.
Well, what
And
I'm
then-
hearing
and then we
from
should
you,
move on.
what I'm hearing from you though is a little bit different from what I'm hearing from you in terms of, you're saying, well, let's not add a bunch of code to take care of every advantage. But what I'm hearing from you is let's build our code in such a way as to not necessarily add a lot of code at the time, but make it structured so that it can be changed in almost any way.
Yes, yes. And if I wasn't having so much fun with this conversation with you all, I would be getting to the slides and showing you some things. But I'm sorry, this is just too enjoyable for me. Okay, let's move on. Okay, so here's some pathologies that, and I use the term pathology rather than smell. A pathology in medicine is a manifestation of a disease. So in software, these are pathologies like rigidity. These are hard to make a change, hard to repurpose the code. Viscosity, you got to slog through it. It's just hard because it's so thick to be able to make changes where you need to make. Complexity, it's hard to figure out what it is. It's like a Rubik's Cube or whatever. Opacity, you can't understand it, so it's hard to change. And brittleness, you're scared to change it because it'll topple down. You know, all these different things are related to other things. So these are pathologies, and what's interesting is each one of these pathologies represents a specific quality or set of qualities that are missing in our code. Okay. So you can get away with it on small projects. As projects get bigger, it can become a lot harder. Okay. I know, when I was doing little school projects and stuff like that, it's easy to get away with writing code in any way you want. But when you start working at 100,000 lines of code and beyond, boy, you gotta have it down. You gotta have good coding standards, and everybody has to agree on it, or else it does get to be sticky. So, software quality affects maintainability and extendability. Things like we want our software to be clearly about one thing, each piece of code about one thing, defined in a single place, hide its implementation, be self-responsible, self-reliant, easy to test, and not intertwined with other objects. And I have terms for each one of these things, so that's what I want to do with you. I'm going to go over these terms. So the first term is cohesion. Probably heard of that. I use the term differently. We in development use the term very differently than most people. I mean, in Answers.com or Webster's, cohesion is a synonym for adhesion. That's not how we use the term. We are, after all, developers, and we have the right to overload terms. So for us, cohesion means about one thing. Single-mindedness. Okay? As my esteemed colleague, Dr. Daniel Rossthorn says, no schizophrenic classes. Scott Bain says, keep entities single-minded, not God objects, like Alan Chalaway says. I said to Alan one day, Alan, why do you call them God objects? Because they try to do everything? He said, no. When you look at the code, you go, oh my God. So, again, software development is very much related to our understanding of the world through language. So when we say about one thing, what we mean is the thing that we can name through a word or a phrase. Okay? If we can name it, then we can understand it. We have a handle on it, so to speak. So classes can represent any number of things, tangible or intangible. They can also represent processes or relationships, even abstract entities. So there's two kinds of cohesion I want to talk to you about. Class cohesion, which is making our class be about one thing. How do we make a class with something that's very complex? Like, that's easy for a simple situation, but let's say I want to model a person. Persons are very complex. They have walking behavior and eating behavior and talking behavior. How do I handle that? How do I model that and still be cohesive? Delegation, aggregation, composition. Yeah, in other words, my class contains, my person class contains a class that has walking behavior, a class that has eating behavior, et cetera, et cetera. And those might have other composed classes, et cetera, until I get down to very simple. Now, you do end up with lots of little classes as a result. And the first time I saw software like what I'm advocating for here, I thought the developers were crazy because I didn't understand what they were doing. I saw this program that had like 50 classes in it, and I said, I could do it with 3. Thinking, oh, that much a better program. And what I didn't realize was that my code would be so hard to debug and so hard to extend because all those issues were intertwined with each other. Let's take a situation where we have just 5 issues in a single class. And let's get back to your testability. How many tests do I have to have in order to test those 5 issues? I can't count that, so somebody please help me.
5 prime tests. I'm not 5.
5, 2 to the 5th.
Yeah.
Which is 64? Again,
It's actually
5 factorial.
Yeah.
So it's even more.
Yeah.
Depends on
Right.
what the issues are.
In other words, a lot. Yeah, it does depend upon what the issues are, but I'm saying they're not orthogonal. They could perhaps interact with each other.
It's more than 5.
It's more than 5.
Right.
So much.
You're hired.
Now, let's say I take those 5 issues and break them out.
says 120.
Okay. That's a lot. That certainly would not make me want to test it. Let's take those 5 issues and break them out into 5 separate classes. How many tests do I need to verify that they all work?
You could say the same number. It's the relationship between the issues is the important item. Whether if the relationship exists in reality, whether you put them in 1 class or 5 classes, if you need to test the relationships.
This is a good question, but not necessarily true. Here's why. If my class encapsulates the issue, that is, if I only deal with that issue through my defined interface, they're separate from each other, then I don't have to have tests that deal with the interaction between them.
So you are stating that the problem is that they are 5 separate issues, independent issues.
If they're separate issues within the same class, since I don't have encapsulation within the same class, I don't know for sure that they're not interacting. If I break them out into separate classes, I can be certain that they won't. Except in the specific ways that they can interact with their interface.
You're saying that if you break it up into classes, then the relationship between the issues becomes clear.
Correct.
Because you have to script across them.
Right, but isn't it the job of the tester to verify that? So, but the tester doesn't. The tester's going to verify it.
I want to be the tester. I want to be the guy who says, at the design level, hey, this guy's going to be testing stuff, and he wants to, have a weekend off. He doesn't want to be working 24/7. And so I want to make it easy for him. Not only easy for him, because if life is hell for him, it's going to come back to me, right? He's going to be throwing all these bugs over at me, and I won't have a weekend either. So I would like to say up front, how testable is my design? There's also method cohesion. Method cohesion is about fulfilling some functional aspect of that one thing. Okay. I can delegate to private private methods if I want. But my public method basically has one thing that it's dealing with. Here's some pathologies of poor cohesion. Basically difficult to understand and debug, has multiple issues, hard to change the code. And some things, like overly generalized interfaces, can lead to poor cohesion. And it makes it very hard to refactor code when you have multiple issues in the same class.
All right, what's an example of an overly generalized? Give me an example of an overly generalized interface.
Do.
Yeah, do it. The do it method. A lot of APIs that try to do a whole bunch of different things, and you can see that they have these huge parameter lists, can be overly generalized. And what I find is that we're using those APIs for many different reasons, and as a result, because we have many different kinds of dependencies on those APIs, that can create cohesion issues.
What do you count as an issue? Saying it has issues, multiple issues. I mean, a class is going to have multiple methods, right? Typically.
Yes.
So, I mean, you're not saying a method is equated to an issue.
Oh, I see. Good question. So you're saying, when we say, what is that one thing?
Yes.
Excellent question. And this goes back to the idea of language. If we can name it, if we can give it a good name, then we can say that that's about one thing. Now, notice that there are levels of precision of understanding. One word can represent many things, and those many things have many different words associated with them, etc. So literally, we can see there's layers of abstraction that we have in English, that we have in our spoken language. Maybe we want to reflect that as well in our code. Yeah.
Should I read that as a criticism of Christopher Alexander? It's the quality that cannot be named.
Yes. Actually, he was quoting Lao Tzu when he talked about that.
Who is he quoting?
Lao Tzu,
Oh, okay. Yeah.
who wrote the Tao Te Ching, the first line of the Tao Te Ching says, the nameless is the core of everything. Yeah. Good.
I find it kind of strange that you picked the word cohesion, though, given that you had alternate meanings for that word, and to many people the word, or the prefix code, might connotate two things.
Yes.
So, using cohesion seems like a way to obfuscate what you're actually trying to say.
Actually, I didn't pick the word. It was Ivar Jacobson who did.
Yeah.
He didn't pick the word, chemists picked the word 150 years ago.
Oh, but that
Said
means something.
chemicals are things that stick to themselves, adhesive
Binding.
chemicals are those that stick to other things.
But I so agree with you. It's the subtle misunderstanding that causes that ambiguity, that causes all of our challenges. And I've heard a lot of developers talk about, oh, my team's very cohesive. It means that we all go out for beers together, we're all tight. That's not what cohesion means. So that's why I'm being very specific about these definitions. And also, once we have these definitions, we can have high fidelity conversations because we're all on the same page with them. Okay. So that's the first quality. The second code quality is non-redundancy. And I prefer the term non-redundant rather than non-repetitive. So we want to make sure our code has no redundancy. And I was teaching a class actually outside of Dallas, and this is about 4 or 5 years ago now. And I didn't know it, but I had a couple of NASA developers in my class. And they immediately said, well, wait a minute, redundancy saves lives. Now that's intentional redundancy, and they're right, absolutely right. I'm talking about unintentional redundancy. Okay. And again, this relates to, and one can come up with a counter argument for pretty much anything, and it's a healthy process. Because if you think about it, it's all ones and zeros, right? So I'm not saying get rid of all the ones and zeros or whatever. What I'm saying is, again, it's that level of precision that we look at it. So sometimes people say, well, I don't know when I'm introducing redundancy into the system. If you're inheriting from the clipboard, you're probably introducing redundancy. That is, if you copy something when you're just about to paste it, ask yourself, do I really need to have this in 2 places? Or could I maybe put it in 1 place and call it from 2 places? A lot of redundancy is pretty easy to spot. There is that last 5% that's very hard to see. And I've become very anal about that now. Because what I find is that a lot of times that last few percent of redundancy is hiding the true nature of the problem. And so I'll use patterns to help me, or other things to help me get rid of that last little bit of redundancy, and then I'll say, oh, look, that's really what the problem is, which is kind of cool. When I talk about redundancy, I don't mean just state or behavior, I mean any number of things that are repeated. And when we say repeated, we mean repeated intention, okay? So let me ask you this. Can non-identical pieces of code be redundant?
Yeah.
Absolutely. Yes, if they express the same intent. For example, a for each and a for loop. If they're doing the same thing, be redundant. What about identical pieces of code? Can it be non-redundant? Again, absolutely yes. If it's expressing different intent. So when we talk about redundancy, we're talking about redundant intent.
How big a piece of identical code can be non-redundant?
again, when we're talking about the level of precision, because like you said, it all goes back to ones and zeros, but it's, when we're talking about intent in code, we start with the user's intent. We start with the user's story or an acceptance test, and we drill down that that intent has other intents underneath it that support it, okay? Until we get down to what we can actually write code for and write a unit test for. Okay. So that's kind of the process. Yeah.
So you could have one person create like a manager object and another person create a supervisor object, not knowing the manager object was already created and did everything that his supervisor object does. That's what that is.
Yes, absolutely. Absolutely.
Intent's the same.
And we see that a lot, don't we? Yeah. So how many times do we have to do something before it gets to be a problem? Twice, 3, 4 times? Actually, wasn't it Hegel who said, when you do something once, it's also twice? Because there's always the thing, and then its antithesis, right? And again, this is something that I've learned from testing. Because if I do something, right, already I've been able to identify that this is a thing. So I know it's cohesive in and of itself. So I want to test it by mocking that thing out with a standard for that thing, right? So I can test my class that uses that thing. So already I've broken it out because I want to separate them out. Okay. So for me, it's one time that things can be redundant sometimes. Pathologies of redundancy. I love Martin Fowler in his book Refactoring, which is a great book. He talks about these smells, one of which he calls shotgun surgery. Shotgun surgery is where you have to make a change in here. That's clearly a pathology of redundancy. We want to have a single authoritative place for any business repair.
So you don't believe in parallel hierarchies?
Oh, interesting question. Most of the time, no. Now, there are exceptions to everything. And sometimes I can't get around it. But a lot of times, and this is the I see a lot of times developers do this after taking my classes, unfortunately, working in patterns, is they create these completely separate hierarchies that just simply could be merged with the original hierarchy.
Right, but then you have objects that do too much stuff.
Well, it depends. It depends. Because the question is, does that stuff go together? Okay. It's back to our person class. Our person class has to eat, walk, talk. Okay. So the hierarchy itself might be person, different kinds of people, etc. They might then aggregate different kinds of behavior. Now we're starting to get into patterns because really there's only 3 kinds of relationships in OO, right? There's inheritance, there's aggregation, and there's implementation, right? Or interfaces. But if we use them in very creative ways, we can come up with all these different kinds of patterns.
But if you're dealing with something like, say, swing or something
Yes.
like this, and you have this common infrastructure that's dealing with the components and attempt in a common way, you're going to have, potentially an adapter for every single one of them.
Potentially, yeah. Actually, yes. I've tend to use adapters more and more. Yeah.
And so you end up with this sort of like, okay, well, the component doesn't quite behave properly, so you have to extend it. And of course, then you have an adapter for the extension. And so you automatically got this parallel thing, and you're thinking, well, sure, I could merge them together, but then I've reduced the flexibility. I want to have them all adapted to a slightly different interface, or something, So it isn't surprising, I have this all over the place, unfortunately, it sucks. But
See, whereas I try to use adapters less and less. Just because at the end of the project, nobody but me has learned anything about the libraries we're using underneath. They go to the next project being just as ignorant as the day they got here, because they only know my code and they don't get to use my code anyplace else. Like a certain individual who wrapped log4j, who will remain nameless, but I think you know who I'm talking about. There's nothing wrong with log4j in the way that for the functionality that it was needed for, but nobody on that project was going to learn log4j because somebody thought they could do it enough better and were wrong. That nobody needed to learn to
See, when I wrapped them up, Virginia, I wasn't there.
Oh, he's not here. But you know him.
Shall we see if we can get through 4 more code elements in the next 30 minutes? Okay. Encapsulation, the third one. We already talked quite a bit about it, and like I said earlier, encapsulation to me means hiding anything, not just state or behavior. Because what you don't know can't hurt you. Did your mom tell you that when you were a kid? It's not always true in life. It is always true in software. If you don't know about it, you cannot couple to it. You are not dependent on it, and therefore it can change and you will not be affected. So that's kind of a good thing. And we say encapsulate by policy, reveal by need. That is, make our scope as tight as possible. Start with making our data private. And then if we need to expose it more, then we can expose it later. Okay? And this kind of harkens to a little bit of my belief about performance, and I don't want to spend a lot of time on it. But I really agree with Fowler when he says, generally, treat performance as a late maintenance issue. Now, I've worked in embedded systems and on little cell phones and stuff like that, where performance is still critical. But you got to remember, I'm an old guy, and 25 years ago, when I was in, doing software development on, 8-bit computers, performance was the only thing that really we focused on, because you had to get a product out. Nowadays, there's things like maintainability that's also important. Okay, and a lot of times they're at odds with each other. So I try to write my code with good quality, with good patterns, with good practices, and then later, when I'm able to profile the code and see where the bottlenecks truly are, then I'll remove patterns. I'll remove code qualities, because I'm doing it for a reason. I'm doing it because I want to optimize those particular paths. And I can't tell you how many times I found the true bottlenecks because my code was understandable to start with. Whereas if I try to optimize everything, it would be a big wasted effort, and it'd probably obscure the real problems anyway. Yes, Steve.
I will say that I tend to agree with that statement with one very important caveat.
Okay.
Performance should be a late maintenance issue, but an early testing issue. That is, you should know very early in the design what your performance is and whether you really are going to have to worry about performance problems.
Like whether you pick the fundamentally wrong architecture.
Right, whether the architecture.
Yes.
I have
Yes.
seen so many projects which got to the end and suddenly discovered, because they didn't bother, they realized very early on that they were going to have to handle 1 million people, and on the second week they could have written a small application and tried it. And it wouldn't be nearly right, but they know whether it was going to have some performance issues or not.
I fully agree. Yes. Yes.
I absolutely agree with that, because you need to design your architecture to handle the expected performance that you need. Because if you don't, you're backtracking. You get down to the end and find that, hey, this thing's just not performing to the customer's needs, and you're backtracking trying to figure out how to correct it.
Most definitely. And this relates back to, can we encapsulate that issue? Because again, if we're building a high availability server, we have to be able to think about that and address that on day one. In the very beginning of the architecture. Fully agree. Yes. So I guess there's really 2 levels of performance. One is architecturally what is demanding of the system, and 2 is the things that we never thought about that turn out to be our true bottlenecks beyond that, or in addition to that. So, good point.
I think the real important thing that they're saying here is so true that you can't test for something that you don't know what the answer should be, right? So if you don't know how long it should take to handle 1 million clients or whatever they are, then you can't even begin to get there at the end. Like Bob
Very
was
good
suggesting.
point. Very good point. So again, the next slide is, can you encapsulate it? So if you can encapsulate it, then you can defer on it, like we talked about before. And there are many ways to encapsulate. Not just hiding things behind interfaces. We can use abstractions. Patterns encapsulate different things. So patterns can encapsulate behavior or cardinality or sequence or selection or any number of other things. So I think of them like my basic tools for my, like a carpenter would think of tools. Patterns help me do different things. Pathologies of poor encapsulation, spaghetti code. The fourth code quality, assertiveness. So let me ask you this. If A has the state that B needs, then who should have the behavior, A or B? You know what? A lot of people say that.
You need a neutral third party sometimes. That's the solution. You take it away from A and B and give it to
Oh
C.
man, I pulled out the graphs that show you why that's not always the right choice. But
not always, but occasionally.
yeah, it's true. It's true. So again, so let's take a concrete example first. So let's say that we want to print a document. Now, who would have the smarts to be able to do that? We want to print a document on a printer, so would it be the document class or the printer class?
You want to vote?
Both?
No.
You have parallel
I mean,
hierarchies?
I mean, I vote for printer, but
No, vote VOE.
Say it in English.
VOT, the printer prints it.
Let's vote on it.
Oh, should we vote on it?
Yeah, that's what I
Okay.
said.
Okay, so who thinks the document should have it? Who thinks the printer should have it? Wow, really? So this harkens back to the days of DOS, where we had a one-word processor floppy disk, and by the way, they called them that because they were floppy. You could actually bend them, and 5 printer install disks. Why? Because every software vendor who needed to use a device had to implement the driver for each one of the popular devices. Now we kind of got away from that because we realized that's not the ideal situation.
Actually, that's not why we got away from it.
get away from this?
We got away from it because Microsoft got tired of writing drivers and said that they could dump the problem on the non-software writers in the hardware companies.
Which is why I
Yes,
get lost in the
but it
printer
wasn't
dialogue.
actually Microsoft, it was IBM, and I was on that team. And I wrote something called Presentation Manager Device Drivers, which implements the graphical system on a particular device. Okay, and it's probably a good idea to not let the application developers do it because it was a bear to write. They were very complex pieces of code. You had to really implement a whole graphical system on a particular device. And it was a lot of fun. It was very interesting. I think that the one who knows about the document itself and its internals would be the document.
Right, but you actually just changed the definition of the problem. The document class is not printing to the printer. It's printing to a graphical device.
Yes.
It's printing to an interface.
See, my point was that it's much easier to publish. My point is it's much easier to publish a document model
Bottom line,
that the printers have to conform to than it was to. And that's what you basically said. is
I
that-
see, I see. So it's inherently ambiguous to say code should print the document on a printer. Because we agree that the primitives that the printer understands to print that whatever line or whatever is in the printer. But the one who says, oh, this document has a polygon here is issuing it. So you're right, it's half and half.
I contend that the interface is Object-C.
Okay.
The jury wins.
Yes, it does.
Object-C. Yes.
By and large, though, we want to kind of prefer assertiveness in our code. And I'm on the West Coast, I can say this. We want our software to be like humans. Self-reliant, self-responsible, non-dysfunctional, right? People in California, they do a lot of therapy to be able to become whole human beings, self-responsible adults. We want our code to be as well. Self-responsible, self-reliant, so that it has its own, manages itself as much as we can. Okay? And the way I remember that is something that Winston Churchill once said. Actually, I don't remember if it was Winston Churchill or Spider-Man's uncle, who said, with great state comes great responsibility. Or he who has the state should also have the responsibility. Or something like that.
Which one on the right?
Pathologies of inquisitive code are, I love Fowler's terms for this, feature envy or inappropriate intimacy. So you have a situation where one class is constantly calling another class because that other class has the state it needs. So what we're saying is maybe that behavior should be in that other class as well. Okay. And of course that improves performance. Fifth code quality, second to last one, testability. And we already talked quite a bit about testability. And I think about testability quite right up front in my code. how easy is this design to test ultimately? Because I got to verify it at some point, and I don't want my tester to be mad at me. It also helps me focus on the right things when I'm designing my code, which is primarily my interface. So one of the pieces of advice the gang before gave us was design to interfaces. And I like what Scott Bain says. He says, think of test as your first client. So when you're writing a test, before you write the code, you're saying, well, what is this going to do? What do I need to give it, and what do I going to expect back? And those are good questions to ask before you dive into actually implementing something. Yes?
So getting back to Stephen's point about testing performance, I mean, if performance is a requirement that's important enough to be tested, it should be, you know, the program should be testable so they can test performance. And that should trump any reason why you wouldn't optimize for performance early on or whatever.
I didn't say optimize for performance. I don't do the optimization. I think you know what your performance is. And you may very well, you're very likely to test and say, oh, we don't have a performance problem. And I'm not going to do it.
And I think he's also, correct me if I'm wrong, Steve, he's saying that when performance becomes a requirement, then we should have a test for it. We should think about that up front.
Performance is a requirement frequently day one.
But not always, and not for everything, absolutely. Would it be surprising to anyone that 95% of the execution time of your program is in less than 5% of your code? Shouldn't surprise any of us. Which 5%? We don't know up front. That's why I say treat it as a late maintenance issue.
Well, and I'm saying it's the global performance. I don't know where the time is being spent. What I want to know is, do I even care?
Yes.
Is it, is it fast enough? And if it's fast enough,
But if you write,
Exactly.
if you write your test at day one and it fails day two, you fix the test so it passes. I mean, you're delaying the, you say delay the performance, but if you're writing a test and you want all your tests to pass, and it doesn't pass because you can't get the performance day one, you spend your time on it there, and you say, okay, I'm not going to worry about that test passing, in which case you pass it.
By and large, if a test fails, you don't want to change the test. You want to change
No,
the
I'm not
code.
saying change the test, I'm saying change the code so that the test pass, even though you're saying, well, let's not worry about performance, actually optimizing performance until later in the development.
No, what I'm saying is there are times when we recognize that performance is a criteria for the program. In other words, if we have a situation where we need a high availability server, then we need to know that we can hit it with 10,000 users simultaneously and it won't die. That's, first of all, there's a very difficult test to model up front. But when we keep that in mind, we know that we have to be able to encapsulate. And there are some tricks that we can use. I don't really mean tricks. I mean some good, solid coding practices that we can apply to give us flexibility in that area. What I'm saying is we don't need to do that all the time because that's being pattern happy again. That's saying, oh, we need, well, I'm only going to instantiate this once. I had I'm not going to tell you the company, but he was a major manufacturing company, and he was the CTO of it, and he was insisting that he reuse exception objects because he read somewhere that it takes a long time to create a new object. I'm like, well, first of all, when the exception occurs, you're going to just go back to the user. It's going to take 1/100th of a second longer before the error message pops up to the user. It's imperceptible. And by the way, when you reuse exception objects, it doesn't work because when that happened and he got an exception, the whole system froze. I said, would you consider maybe creating an exception object like they say you should? So again, we can be overkill sometimes. So I think of testability as a good guidance for design. So if I have trouble testing something, I'll just simply ask myself, well, why? Why is it hard to test this? And invariably, one of these code qualities that we just talked about is the reason. So I know that a lot of times you can't do test-driven development in projects yet because management says, oh, well, we don't have time for you to write tests. But no one can stop you from asking the question, if I were to test this, how would I do it? And oftentimes, this is a great way to get top of mind on code quality, because invariably it will be one of these qualities that will be lacking. Pathologies of poor testability. Oh, and you can see this, and we've already talked about this, right? When we have multiple issues, we have very, very hard to test, easy to write the code, but the tests are forever hard to write. That's cohesion. If we have to repeat the tests all over the place, that's redundancy. If we have too many dependencies, obviously that's some encapsulation. Or there are also test problems for assertiveness. The last code quality I want to touch on with you is, I call it explicit, but really it's coupling. It's the relationship between entities. And we want to make sure that they're intentional or explicit and clear. When we talk about coupling, they talk about weak coupling and tight coupling, and I never could figure out which one is the good one and which one is the bad one. So I like the term explicit coupling or accidental or unintentional coupling. Then it's clear which one is good and which one is bad. And we're not striving for no coupling, because a program that has no coupling is a program that does nothing. What we want is coupling where it should be by the nature of the problem we're addressing, and no coupling where it shouldn't be. Okay. Easier said than done in a lot of ways. There are lots of different examples of bad coupling. Perhaps the nastiest is global variables, because you could couple to that anywhere. Certainly magic numbers and split functionality or overly generalized interfaces could create bad coupling. I'll just touch on this really quickly. There's different other kinds of coupling. We say coupling to the existence of a class that we call type coupling, coupling to its interface or some of its methods, the parameters of those methods. We call that interface coupling. Abstract coupling is coupling just to abstract types. Concrete coupling is when you're dealing with a polymorphic set and you're trying to work through that polymorphic set. Let's say I have different shapes and I want to draw them, but the client is aware of some of the shapes. Oh, that one's a circle, so I have to do some special casing. Then we say we have concrete coupling. That's a little bit of a problem because now the client is aware of at least some of those representations. If a client is completely unaware of it, then it's much easier to extend those representations. Here's a little graph to show you this. The client is talking to this abstract service, has this abstract method called method, and we have these different implementations of method. We would say that there would be type coupling from the client to the abstract service, as well as interface coupling because it's calling the method. Abstract coupling because it's dealing with the abstract type, but if the client was unaware of those subtypes, then we say there is no concrete coupling. Some pathologies of bad coupling are basically special casing algorithms. And when we are aware of those specific coupling issues, then we certainly have encapsulation problems and perhaps even redundancy problems. A lot of times, though, coupling is, or explicitness in code, or unexplicitness in code is a second order effect. We just sort of see that it shows up one day. And the reason for that is that typically it's a result of these other code qualities lacking. So if we have classes that have lots of issues in them, then we'll wind up with lots of different coupling.
So if you have a situation where you have an abstract class or an interface
yes.
that is used 95% of the time, and then you've got a subclass interface or abstract class that you're using 5% of the time, never caring about the actual concrete. So every now and again, you're having to do an instance of it. Would you actually introduce an alternate method to get these special ones? Or would you just go ahead and pay the price of doing the instance of it?
Interesting question. And again, it's very hard to make a hard and fast rule. Generally, if I do have to do an instance of, if my client has to be aware of a concrete type when it's using abstractions.
Not a concrete type. An extended class.
An extended abstraction?
An extended abstraction, yes.
And in its awareness, is it using then in that extended abstraction an abstract method?
Yes.
Generally, that is certainly not nearly as bad as when we're dealing with concrete methods. So the situation that he's describing is we have a hierarchy where we have an abstract class here, we have a subclass of that abstract class, which is also abstract, and also has abstract methods. And then we have concrete classes underneath.
Most of the time, you just deal with the raw-based abstract stuff. Every now and again, you say, well, there are special configuration capabilities or special state I can get to in the subclass abstract class.
Okay, so let's take an example. We have animals. Some animals can fly. They're called birds. And they have this abstract interface called fly, or flyable, or whatever. And then there's different kinds of birds.
Right, but in this case, flyable extends animal.
Yes.
So that you don't want to then turn around and pass two interfaces around. So that because that can get pretty hairy. When you start saying, okay, well, yes, I want to know that this is a flyable and an animal, so now I have to pass around the animal interface and the flyable interface.
Yeah. Now, generally, the way I've seen people handle this is that we have an abstract class called animal, so that's an abstract class. But then we have an interface called flyable. Now we don't.
But flyable doesn't extend animal then.
Doesn't extend animal,
So
but
that means
birds
if I wanna-
are animals that implement flyable.
But that means if I want to pass this animal that happens to be a bird, I have to pass two references.
No. Here's what I do. I pass in a flyable.
Yeah. But the flyable doesn't have access to the animal methods.
No, but the animal is applied. Or
No, you can't have it both ways.
Yeah.
Either flyable extends animal, or they are totally separate types for all your children. I mean, all the things that you pass it to.
Sometimes you get this. You're absolutely right. That in the domain problem, you've got these things that are coupled in the real world. Hello.
Yes.
That's why you've got to live with it, right? Because that's what represents reality. We used to teach a class that for somebody else that down at the bottom, there was this relationship that you would like to pull apart, but it exists in real life in the problem.
Right, so my question was, given the fact that it exists in real life, which is a better model to basically say, get me flyable, if I'm expecting it to be a flyable, or get me the animal and then do an instance of is flyable?
Well, one way to answer that question is to ask whether an airplane, which also implements flyable, can be
interesting.
used in the method.
Good point. Because I was thinking
Depends on
that.
whether you're talking to the air.
I mean, yeah, if you're really in the animal space, then it probably makes sense to pass it as an animal, but if there are airplanes floating around, then it's entirely likely that...
That isn't answering the question.
I guess the answer depends on what level of abstraction you're talking about.
No. The question is a simple one. Should I have a different method that if I specifically want to know if it's a flyable animal, then I call a method to get me the flyable animal versus just calling the get animal and then doing an instance of and then a cast into flyable.
I recommend list.
You recommend a dynamic language, you don't have any guess casting,
That's right. If that's where your problem space is, that's what you use to solve it.
Yeah.
Because we had a system that had a lot of these things, and the developers were complaining that God, I hate all these stupid instance ofs and cast because it's a smell.
So Rod, in 3 words or so,
it.
gave me the answer.
Having to go down the animal and flyable. I mean, go with flyable and then find a way to get back to animal when you need it. That's the way we do it.
Yeah.
Ask the animal to travel from point A to point B. Let it
Ask
figure it out.
flyable if it's animal.
Right, which
Where
is
you
back
go.
to Steve. What Steve was saying is, if it's as long as airplanes are not flywables as well. Yeah.
I
So
mean, there's some
kinda-
coupling you're introducing in there, but from a usage point of view, I mean, you got to be practical when you're developing this stuff. You can't be so abstract that you're just killing yourself with
Yes.
all these casts and everything else going on. You got to be able to have some coupling there that's going to be acceptable.
There's a great solution here, which is, fine, you have flyable, you have animal, you now have a flyable animal interface, which simply puts the two of them together, and that's what you pass in.
That's another possibility. I don't want to go too deeply into it because I just got 4 minutes left, but these are the kinds of things that I love talking about and we get to cover in my class and a lot more detail. So, the 6 code qualities that we talked about: cohesion, non-redundant, encapsulated, assertive, testable, and explicit. These are the things that I look for in code. If I look at these letters, the first letters, it makes the word create, C-R-E-A-T-E. So it's an easy way to remember it. I want to create quality in my software. Okay.
We end up with redundant software at that point.
Sorry?
We'll end up with redundant software.
Yeah. Little and big.
These qualities give us some guidance. They help us. They help us make code that's easier to find bugs. That is, we're dealing with issues only at one time, and that it's able to manage complexity. We're able to manage more complexity more easily. So if we agree these things are good, then we can evaluate designs based upon these 6 code qualities. So I just want to wrap up, and because I want to get you out of here by 9 o'clock, which is just 4 minutes away, and say thank you, first of all, thank you very much. This has been super fun for me. You can read my blog and also get in touch with me through my blog if you want to chat more about this. I also am on Twitter at agile_design. If you want to delve into these concepts much more deeply, come to my class, June 30th and July 1st at the SeaTech area Marriott, and I've given you a flyer with information on that. Yes?
So I'm not a Twitter user, but let me ask you, if I was to subscribe to your Twitter thing, whatever they call them, would you just be talking about agile things, or would I have to hear about other things?
I don't talk about what I had for breakfast
He
or
doesn't
anything like
tell
that.
you when he got out of the shower.
Yeah.
Or what he
We subscribe to it. So I actually don't tweet a lot. I actually kind of blog about as much as I tweet, like once or twice a week. So I only talk about agile design issues. I mean, I'm on a theme of talking about code quality this month actually. And I just want to thank you so very much. It has been so much fun and great questions.
Where are you based out of?
I'm based in Bellevue. Cool.